Hello and welcome back. Today, we have an exciting topic to discuss: concurrency in the Go programming language, which is known for its exceptional support for concurrent programming. In this video, we'll explore the concept of concurrency, its importance in modern software development, and provide practical examples to help you harness the full potential of Go's concurrency features. So, let's jump right in. Understanding concurrency. Concurrency in Go allows us to efficiently execute multiple tasks concurrently, making our programs faster and more responsive. Unlike traditional multithreading, Go uses goroutines and channels to achieve this. Goroutines are lightweight, managed by the Go runtime, and enable us to run thousands of concurrent operations with ease. Channels facilitate communication and synchronization between goroutines, preventing data races and ensuring safe concurrent execution. Creating goroutines. To illustrate, let's start with a simple example. Imagine we want to download multiple web pages concurrently. In Go, we can create a goroutine for each download task. This enables us to download multiple pages simultaneously, improving our program's performance. In the provided code snippet, we have a main function that initiates the download process for a list of URLs concurrently. We use a for loop to iterate through the URLs and create a goroutine for each URL by invoking the download page function with Go download page function. This allows multiple web pages to be downloaded concurrently. We also include a sleep to ensure that we give the goroutines enough time to complete before the program exits. Using channels for communication. Now, let's explore how channels help in coordinating goroutines. Suppose we want to calculate the sum of numbers from 1 to 1000 using multiple goroutines. We can use channels to distribute the work among them. In the second example, we have a main function that orchestrates the calculation of the sum using goroutines and channels. We create a channel called numbers to send numbers from the main goroutine to worker goroutines and another channel called result to receive the partial results from the workers. We then spawn multiple worker goroutines using the worker function, which calculates the partial sum of numbers it receives from the numbers channel and sends the result to the result channel. In the main goroutine, we send numbers from 1 to 1000 to the numbers channel using an anonymous goroutine. This distributes the work among the worker goroutines. Finally, we collect the partial results from the result channel and sum them up to calculate the total sum of numbers from 1 to 1000. This example demonstrates the power of channels in orchestrating concurrent tasks and safely collecting results, enabling efficient parallel processing of data. Benefits and conclusion. Go's concurrency features offer incredible benefits, making it a powerful choice for building scalable and efficient software. By leveraging goroutines and channels, you can easily parallelize tasks and improve your application's performance. This is just the tip of the iceberg when it comes to Go's concurrency capabilities. In conclusion, mastering concurrency in Go is essential for any developer looking to build high-performance applications. We hope this video has given you a solid introduction and practical insights into the world of concurrency in Go. Please don't forget to like this video, subscribe to a channel and hit the notification bell to stay updated on all my latest content. Thank you for watching, and I'll see you on the channel.